one of a small group, a handful of people that helped us set up our aquaponics thing. Let me ask, real quiet. All right. So anyway, he helped us get our aquaponics thing up and running. He was the smartest of the group. He had the right answers when some of them had wrong answers, and we appreciate him for that. And he stuck around. He's been helpful and good. He's likable. He's good looking. And he can only stay till after lunch, but he is going to take a group to do a tour of our aquaponics greenhouse at the lunchtime. And I'll tell you more about that later. But here's Dan.
All right, thank you. Morning. How's everybody doing? That's good. Everyone get coffee, donuts, all that? All right, good. Sweet. Well, as Scott mentioned, I had the pleasure and the opportunity this past summer to work with him and a few other individuals to put in the aquaponics system here at the zoo. So just jumping on in. This morning, I wanted to talk a little bit, just give a technical overview of aquaponics, since I imagine a lot of folks here have heard, have either looked it up online or heard people talk about it. And I just wanted to give a really brief overview to get everyone on the same page. Then I was going to talk about the zoo's backyard aquaponics system and just what were some of the design considerations into building it, as well as an example of how another installation here in the city integrated aquaponics into a landscape design. And then some Q&A at the end, because since aquaponics has been a buzzword for a while now, there's a lot of misinformation out there and a lot of magic associated with the term, and so I just wanted to create a time for folks to ask questions or get clarity, because it is a legitimate strategy in integrated agriculture, but it has to be applied in wise ways. So I just wanted to make that an opportunity for the group. So, well, I'm the Chief Growing Officer and Environmental Engineer at Waterfields. Waterfields is a business here in Cincinnati that's dedicated to creating urban ag businesses. We're just starting up with a microgreen business in Lower Price Hill. We're growing indoors in a warehouse under grow lights. So we're taking the approach of, I guess, the all-of-the-above approach when it comes to the future of food. We're focusing on growing indoors, under lights, but we recognize that we'll never replace field crops, we'll never replace organic gardens. This is just a part of the picture. So in just a couple of the restaurants, to give you an idea, in case this is your weekly lunch rotation, you might be eating our product. So, and here's just an example of what we're growing in now. Vertically, we're on 6 levels, under T5s, and right there is our product. This is our spicy mix. It's one of our most popular. But moving on to aquaponics. So just a quick show of hands, how many folks have heard the term aquaponics? Excellent. So, the brief overview is fish poop, then we work with the poop to make it something that plants can eat, and then the plants clean the water up to a certain extent, and we send it back to the fish. It's a closed-loop cycle regarding water. It uses less water than traditional ag, but there are still many inputs, energetic, and also food. It goes into the system to feed the fish. And you do have to supplement nutrients to some extent. So just to give a really broad overview, this is the technical side that I was talking about, to get everyone on the same page. As we were saying before, fish grow in a tank. We remove the solids. We have biofiltration, where we convert all the toxic ammonia into nitrates, which is non-toxic to the fish. Then we re-oxygenate it, because oxygen is consumed by nitrification. Some of the water is split off to the hydroponic system, where the plants uptake some of those nutrients, and then that water is dumped back in. This loop right here, I put it in there just to indicate that it's not always in a closed loop. A lot of systems are out there continuously cycle the fish water to the plants, and this isn't always advisable because of the nutrient concentrations. Then you lose all control of your nutrient concentrations. It works for backyard systems and it works for hobbyists, but if you're looking at commercial systems, you need to have much stricter management, or else your nitrate levels in your plants will be exceptionally high. So aquaponics is not a new idea. It's just something that's been evolving over time. This is a photo of Chiapas from ancient Mexico. The idea here, it's floating raised beds over a body of water. Another example would be in ancient China, when you have the polycultures of carp with the rice paddies. So the idea here is just that we're taking a very extensive principle that worked with nature, and now we're kind of bringing it indoors, and we're controlling it a bit more strictly, and giving all the processes affiliated with aquaponics fancy names. But it's something that's been going on for a long time. So this is an example of a recirculating aquaculture system. I believe this one's in somewhere in the Northeast. The name eludes me right now, but integrated with a hydroponic greenhouse that's up above. So there are a lot of opportunities here. So the backyard system. The backyard system here at the zoo. The focus here was to build a system out of common materials that folks could pick up at most hardware stores or hydroponic stores. Had something that's very easy to use, that was productive, it was relatively affordable, and also resilient. A system that would not quickly collapse if something started to go wrong. And so inside of this greenhouse, which is over by the Base Camp Cafe, we put this system together. Here's the team that did it. On the team we have Scott Berlin, who already spoke, Adam Wyman from Elements Pro, Kevin Savage from Cincinnati Hills Christian Academy, myself, and also Pete West, who almost got cut off the slide, from Self-Sustaining Enterprises. Pete was kind of the catalyst to bring everyone together, and unfortunately his picture is not there. But to just show what's going on here, the system inside the greenhouse, which if you go on the tour, you'll be able to check it out yourself. We have two independent systems on each side of the greenhouse, and this is one here. We have our culture tank in the front with a water pump that moves the water to the back of the house, where it goes through a biofilter, and then down through our grow beds and back in. So this is a closed loop cycle, continuously cycling the fish water to the plants. And as I mentioned before, this is really good for low maintenance operations where you don't necessarily have the capacity to do continuous or online water quality monitoring, and it takes good care of the fish. So just stepping through, this is the culture tank. This, I believe is a 250? 200. Yeah, 200, a gallon tank. And you can see a couple of our white catfish right here hanging out, doing their thing, which is doing their business so that we can use it. So culture tank, our biofilter, this is something that you might have seen in any pond work that